Hello, hello everyone. This time we go on with the trigonometric function. This time we will be focused on the graph. This session will be very interesting. If you are observe the graph and they have some tricks. I think I try to make this is a little funny. And for this session, I'm more focused on y equals to sine x. Okay, the graph. And okay, and for the y equals to cosine and tangent cotangent, in fact they are little similar, but the way that I introduced today, you can application this one to the cosine and the tangent and cotangent. So let's see. First, let's review what is an angle here. Such in this circle, okay, we have the starting side. Okay, starting side is on the x-axis on the positive side, right? And then this will be the one side will be raised up, another side will always stay on the center point. So when they raise up, they form an angle, and then we have angle here, okay? And then we have other conception like we discussed about radius, right? The radius, okay, angle, okay, and the sine x, sine alpha is opposite side divided by hypotenuse side, right? Okay. Since we are based on a circle, so we can see there the end line, the second line, when they form an angle from here there and then come back to one circle is equals to 360 degree, am I right? Or equals to 2 pi. Okay, so observe here. So this is the basic formation of y equals to sine x. Y equals to sine x. Okay, and we can see here. Okay, is the we call here we have a concept we call a wave frequency. So this wave, like this way, in fact, it will frequently happen, right? If you keep on go to 2, 4 pi, 6 pi, even come back negative 2 pi, they will keep on going, right? The same shape. But for 2 pi is a circle, right? Is a kind of one cycle, right? If we go to 4 pi, they just go to the similar cycle. So we call this 2 pi as the wave frequency. Another concept you need to know is like the wavelength. Wavelength. What is wavelength? Wavelength is within this frequency, the highest point to the lowest point. Definitely based on the characteristic of the sine x, we know the highest point is 1, the lowest point is negative 1. So, right? So their wavelength is 2, right? Their frequency is 2 pi. Okay. Now I give a complicated. This is simple, right? I give a very complicated expression of the y equals to sine x. Here's y equals to k times sine a times brace x plus b brace back plus c. What's that mean? Is that they have add a lot of coefficient, right? First, here's a plus b, and then here's plus c, and then times x, and also here have a coefficient of k. So what's this? What are those coefficients will be really affect their original graph? That's what we want to know. All right. Okay. So I try the first example is y equals 2 sine 2x. Sine 2x we can treat as like ax here, right? Ax here. Let's observe what happens here. We can see when here a equals to 2, their frequency is not 2 pi anymore, right? The one frequency will be 1 pi, right? Will be 1 pi. So 2 pi will be 2 frequency. So the A here, if you have A here, that what's it affect? It's affect the frequency. If the A is bigger than 1, the frequency will be smaller than 2 pi. If the A is less than 1, the frequency will be what? Bigger than 2 pi, right? So here, if A is 1 over 2, so the frequency will be 4 pi. And let's keep on to learn what's the others. Here I have 3, right? 3, then you can see the frequency in 2 pi, they already have 3 frequencies. So one frequency is 2 pi over 3, right? But others no change, right? Others no change, right? So, okay, let's go to look here. I changed. It's not A here, but K here. K here. If K here, what will be really a fact? So you see here is 2. If it is 2, we observe that 2, which means every x result will be have 2 times it will become y. So just based on our understanding, there will be the what? The what? If it is 2, which means that what? The length, the wave length, right, will be increasing to 2. Am I right? Before he's 1, now he's go to 2, but it did not affect the frequency. Am I right? So if I go to the 3, the length, wavelength go to the 6, right? 3 times. How about it's negative? Compare with that, compare y equal to sine x and the y equals to negative sine x. Their graph is based on this x-axis as a mirror. We remember x-axis, if y equals sine x is like this way, right? And then come back like this way. Am I right? So it's exactly the opposite. Based on the mirror, it's reflect itself. Because why? Because every x they got the negative y. That's why, right? Because this is y-axis, right? This is y-axis. X never change. Only y change in the opposite way. Okay, so here is plus 1. What I'm writing there is what? Is C. Okay, is C. Let's see what plus 1 bit looks like. If plus 1, so every time we get y, they will move y axis right here since plus 1. So even supposedly start should be here 0. They raise up, right? So if it is 1, if it is I forgot this as m or something, they will affect the y-axis. If it is positive, then we'll go up. If it's negative, we'll go down. Okay, similar things happen. Let's observe. What is y equals to x plus 2 pi? Is there any difference of y equals to sine x? Totally same, right? And why? Because if we come back and based on our this one graph, you can see that the graph, the second line keep on swirling, and then go to go to one cycle and come back again. If they come back to A alpha angle again, is there any difference? Is there any difference of this angle? The x divided by hypotenuse? No, right? No, right? Even they have another swirling one more circle and lying on the same A point, same. So that's why 2 pi is just one cycle. So if they increase in 2 pi or 4 pi or whatever, they will not affect their sine and cosine. Okay, let's keep on observe. Okay, so what else? This we already learned. Plus 1 plus 2 pi. And what else? If it is x plus 3 pi over 3, what will change? So we can observe here. First, the cycle, the frequency will not change, still 2 pi, right? But the position will, this supposedly should be 0, should be here, right? Move to the left side of the 3 pi over 3. The length is pi over 3. Pi over 3 is what equal to what? A little higher than 1, because pi equals to 3.14, right? So a little higher than 1. That's exactly here. So that's a fact because it's the x, right? When x equal to 0, he already likes to 3 pi over 3. So you can see here, when x equal to 0, we can see here, in fact, is y equals to sine pi over 3. It's not the sine 0. That's why. Okay. So since we already know this, hello. So let's go to see the examples. Examples is here. Y equals to sine brace 2x plus pi over 4 brace minus 1. So first I draw the common factor of 2 here. So 2 is the coefficient of x and it become x plus pi over 8 brace inner and then minus 1. So here, since the coefficient of x is 2, so what's that mean? Coefficient of 2 of x is affected the what? Affected what? Affected the frequency, right? Since it's already 2. So normal frequency is pi. So 2x, the frequency will be 1 pi. So let's see that. In fact, this is the blue line is exactly y equals to 2x. So you see that from 0 and the pi, right? This is 1 second. So let's just observe for this part. This I will write in here. Observe, start from here and end from here. Okay. Observe for this part. Observe for this part. Observe for this part. Okay. Look at here. What's their move? First, here is -1. Here is a pi over 8. So this 9 move to left side pi over 8. So exactly like this. So move pi over 8. I'm just comparing the highest point. Pi over 8, right? And then they move down 1, right? So move down here, right? Pi over 8 and move down. So exact the 9, just exactly the curve, the y equals to sine 2x. The curve will be move left pi over 8 and move down 1. So this curve just move, right? So you can see this difference, right? If it is just y equals to sine x, then the difference is there will be the frequency will not be 1 pi but be 2 pi, right? It will be 2 pi, but their wavelength still the same, still the 2, right? Okay, so now let's see another example. 5y minus 1 equals to sine 4x. In order to make this simple, I move the coefficient 5 and 1 to the right side. So you can see simplified is equal to y equals to 1 over 5 sine 4x plus 1 5. Same here, I draw 2 9. Okay, so you can see here the start from 0. So it should be what? So this should be what? Y equals to 1 over 5, and then let me write in here the blue one. Let me just choose the blue here. So blue is what? Y equals to what? 1 over 5 over sine 4x, right? Okay, here, this is 1 plus 1 over 5, which means this will be raised in the y-axis, 1 over 5, am I right? This is 1, 1 over 5 is exactly here, right? 1 over 5, right? 0.2, right? So exactly right. And then let's just observe why this, let's see the frequency, wave frequency. So it starts from here and then end up here. So it's like a 1 point what? 1.6, 1.7. So let's see why. Because let's see how the frequency is depends on here 4. So since it's 4, the frequency is what? The frequency is 2 pi over 4. So is pi over what? 2. Pi over 2 is exactly here, right? Exactly here. Pi is 3.1, so 1.6 something like that. So exactly here, right? Yeah. So the frequency will be start from here and ends from here. This is okay. Okay, right? So here, in this graph, we don't encounter any kind of left move, right move because x don't have any effect, right? But here is 1 over 5, so which means the frequency supposedly should be no, the wavelength supposed to should be 2, right? But right now, since just the 1 over 5, so now will be 2 over 5. So 0 will be from the highest point to from the highest point to the lowest point will be 0.5, 0.4, and the half will be 0.2. It's also 0.2. So exactly right, right? So I already introduced the change of the different kind of format of the y equals to sine x and how they are changed based on a different coefficient, different factors in this term, different terms in the function. So I hope you totally understand, and you can draw some science graph just based on those kind of the observation and the conclusion that we draw. Okay, so thank you very much for joining this session. Thank you. Have a nice day. Bye bye.